want to look at these brief revision questions. 1. Convert 10 raised to the power 5 Fermi to Armstrong. 2. State the dimensional formula of modulus of elasticity. So, if you want to convert from one unit to another, you need to know the relationship. So, we're going to be fast and smart about it. So, number 1, the solution is 1 Fermi is equivalent to 10 raised to the power minus 15 meters. And we're given to 10 raised to the power 5 Fermi to convert. So 10 raised to the power 5 Fermi would be equivalent to what? In this case, we simply multiply. So that becomes 10 raised to the power 5 times 10 raised to the power minus 15, which will give us 10 raised to the power minus 10 meters. But that is not the final answer. What the relationship between meters and Armstrong? We know that 1 Armstrong is equivalent to 10 raised to the power minus 10 meters. And we are to convert 10 raised to the power minus 10 to this. So we simply divide. So we now have 10 raised to the power minus 10 divided by 10 raised to the power minus 10. And that will give us 1 Armstrong. That is for question 1. Then for question 2, state the dimensional formula of modulus of elasticity. For us to know is either we know the units. If you want to state the dimensional formula of a particular quantity, you either know the units or the formula. So what is modulus of elasticity? What we call Young's modulus. If E is the Young's modulus or modulus of elasticity, then we can say that modulus E is equal to tensile stress all over tensile strain. Tensile means compressible. So E now will be equal to what is where stress is given as force per unit area and strain is given as extension per unit length. So we can write E to be equal to F over A divided by E over L. This is the force in Newton, area in meters square, extension in meter, length in meter. So we can further say that E can be given as F all over A times L all over E, which we can write as FL all over AE. This is in Newton, so we can say that E is equal to Newton meters all over meter square meters. So this will take care of this. So the unit of modulus of elasticity is Newton per meter square. So what is the dimension? We know that with this we can get the dimension. N is the force, and we know that force is mass times acceleration, which the dimension will be given as m L t raised to power minus 2. This is dimension of mass. The dimension of acceleration is L t raised to power minus 2. Remember, this is divided by L square. So we can now write this as m. One of the L will take care of this. So we now have L raised to power minus 1, t raised to power minus 2. That is the dimension of modulus of elasticity.